Hey guys, back at you here with day 62, inverse functions. So the AP test is going to want to make sure, this isn't a very heavily tested idea, but it comes up from time to time. The idea of what happens with inverse functions. Well, we first learned about inverse functions, I want to say in Algebra 2, maybe in pre-calc. I think it's in Algebra 2, though. So let's think about what we know about inverse functions. So what we know, if we remember, okay, is the notation for it. So that f, right, in the superscript -1, not to be confused with f prime, right? Don't get that and f prime mixed up. F with the superscript -1, that means f inverse, right? So f to the -1 of x, right, that weird symbol there, is the inverse of f of x. Okay. What we know about inverse functions as well, so right, this is the notation here. That's the notation for inverse. Sometimes they use that in a problem, so you know we're talking about inverses. Sometimes they use a property of inverses, right? So let's say we have two functions, g of x and h of x. And you should remember this from Algebra 2. G of x and h of x are inverses if and only if g of h of x equals h of g of x equals x. So when we see that statement, right, that's how you guys tested, right, when you found an inverse. Think back to Algebra 2. You confirmed by looking at the composite of the two functions, and when you do g of h of x or h of g of x, you should get x for both answers. Okay. Now let's talk about how we solved these from back in the day. Well, one of the common ways that people teach you to solve inverses is you switch x and y and solve for y. Okay. So if you wanted to find the inverse of y equals x squared plus 2, you'd switch y and x, go ahead and solve for y. Well, that concept creates the fact that inverses are always reflections about the line y equals x. So let's take a look at a graph here real quick. Here is the line y equals x. So let's say my f of x looks like this. Well, f inverse would just be a reflection about the line y equals x. So it would look something like this. We have f of x, we have f inverse of x. Okay? Now, for every point AB that's on f of x, so let's take a look. I'm going to call this point right here A comma B. There is a corresponding point on f inverse that has the x and the y flip-flopped. So there's a point up here somewhere that is the point B comma A. Okay? Now the relationship we get with derivatives, right, slopes of tangent lines, has to do with the points that correspond like this. AB becomes BA. So maybe AB is 0.42, right? So if 4,2 is on f of x, then I know 2,4 must be on f inverse. Okay? That's how this works. Now what happens then is the slopes of the tangent lines at those corresponding points, notice they are not the same x value. That's going to be very, very important, right? On f of x, the x value is a, but on f inverse, the x value is b. Okay, so they're not at, they don't have the same x values, but these 2 points, right, AB and BA, have slopes that relate to each other. So let's take a look at the slope of the tangent line here. So if I draw a slope of a tangent line, let's say I say this slope equals m. Okay. Does it look like the point BA would have the same slope? Well, to me, it definitely doesn't. Okay. It looks like a very different slope. However, notice both slopes here are positive. Okay. The rule is this slope up here is always the inverse of this slope down here. So if we call it the slope m for f of x, the slope up here would have to be 1 over m. So again, if this slope, to put numbers with it, let's say this slope was 1/2, the slope up here would be 2. If the slope here was 2/8, no, 2/81, the slope up here would be 81 over 2. Okay? So they're reciprocals. They're always the same sign, right? It's positive 2 over 81, and then it becomes positive 81 over 2, right? It's not like perpendicular lines where we do the opposite reciprocal. We keep the sign the same, but we just flip the slopes. Usually I don't see this very often on the free response, but you never know. It could come up on the free response. I usually see it asked in the form of multiple choice questions, and they tend to be really tricky. Okay, so let's take a look at an example and then we'll call it a day. So here I have a table of values. Notice I have 3 different x values. X is 2, 3, and 6. And then I know the corresponding f of x values of 6, 8, and -5 with f prime values of -4, 1, and 7. So here's something they might say. They might say g of x is a function where f of g of x equals g of f of x equals x. What do I know about g and f based on that statement right here? Well, that's our test to show that f and g are inverses. Okay? So we want to find g prime of 2. Okay? That's our goal. So, how do we do this? What do we think? Well, let's think about what we know here. Oh, and I see a mistake in my table. Let me just change something real quick. Sorry, I'll just change the question. Find g prime of 6. Sorry, that was unsolvable on the other one. So here's what we want to think about. We want to think about how f and g relate, right? So we want to figure out the corresponding part with f. Okay? So here's what we know. Okay. So we know 3 different points on f. We know the point 26, the point 38, and the point 6, -5. Okay? So let's think about those 3 points we know. 2, 6, 3, 8, and 6, and negative 5. So all those points are on f of x. So all those points but reversed should be on g of x. Okay? So the point 26, what does that correspond to on x, g of x? Well, the point 26, we have to flip them around for 6, 2. This point we have to flip around to 8, 3. This point we flip around to negative 5, 6. So here's the tricky part. A lot of people, to find g prime of 6, they look at 6 in the x column and they go over to f prime and they see 7. So they say, okay, it's the inverse, so the answer is 1/7. That's where you need to be very careful, because g prime of 6 doesn't match up with f prime of 6. Okay? If we notice, when x is 6, g of x is 2. That's corresponding with the point 26 on f. So, as I'm asked about g prime of 6, I actually want to look for 6 in the y column, not in the x column, right? So I know that f of 2 equals 6. Therefore, I must know that g of 6 equals 2, and I know that these two are the points that correspond, right? So this whole part of the table is not helpful for us, okay? It's there to distract you and to get you the wrong answer. So g prime of 6 is actually going to be, this will be the inverse of f prime of 2. Remember I said the x values don't match up, right? The x value of 6 on g corresponds to the y value of 6 on f. So our actual answer here is the reciprocal of negative 4. So our answer, g prime of 6, should equal negative 1/4. As you can see, these problems are pretty tricky. Usually they just put in one problem like this on the multiple choice, but I thought we'd take a look at it today. We'll take a look at some of this stuff on Monday, as well as getting ready to quiz on our local linearity and L'Hopital's rule. I'll see you guys on Monday. Have a great weekend. Talk to you later. 2 Chainz, bye.